Okay, today we are doing Algebra 1, Section 1.4, and this section talks about solving absolute value equations. So this may be a review, or maybe this is the first time you're seeing this. Anytime you see these straight lines right here, it means the absolute value. So this would be read as the absolute value of x. So what is the absolute value? The absolute value just means how many units away from 0 is the number. Because absolute value refers to distance, it is never negative. So, one thing I want you guys to start doing, when you see something like this, instead of saying to yourself that this says the negative absolute value of x, we're going to say this is the opposite of the absolute value of x. Keep in mind that the opposite of the absolute value of x does not equal the absolute value of the opposite of x. This will make more sense as we do more examples. So let's look at, if we were to just look at this right here, this says the absolute value of 2. Well, I know that 2 is 2 units away from 0, so the absolute value of 2 is 2. But if I have this opposite on the outside of it, this really means the opposite of 2, which is negative 2. Now, look at this case right here where we have the absolute value of negative 2. Well, negative 2 is also 2 units away from 0, so the absolute value of negative 2 is 2. And we can see that these are clearly not the same. So let's look at how do we solve absolute value equations. I'm having trouble with the paper here. Okay, so let's say we have this problem, the absolute value of x minus 4 equals 6. So if you recall, if I want to know what x value gives me, for instance, the absolute value of 2, there's going to be two answers to this. Because when x is 2, its absolute value is 2. When x is negative 2, the absolute value of negative 2 is 2. So to answer this one, it would be negative 2 and 2. Keep in mind that most absolute value problems have two answers. In this case, we need to set up two separate equations. Okay, so either x minus 4 equals 6, just the way it's written without the absolute value signs, or x minus 4 equals the opposite of 6, the opposite of whatever's over on the right-hand side. So now we have our two equations, and we're just going to solve those. These are pretty simple. We can see that we're going to add 4 to both sides, which I did here. In this case, x would give me 10. And in this one, x is negative 2, so x equals negative 2 and 10. Not imperative that you write them in order. I just kind of like my numbers to go in order. So negative 2 is less than 10. It's listed first. Remember, absolute value problems generally have two answers. So you have to set up two equations. So sometimes these absolute value problems don't have a solution. Let's look at this problem. The absolute value of 3x plus 1 equals negative 5. Well, don't forget that all absolute values are positive. So if this number is negative, there is no solution, because there's nothing I can put in here and then take the absolute value of it that will give me a negative number. All right? So watch out for that little trick. So let's solve this problem. The absolute value of 3x plus 9 minus 10 equals negative 4. The first thing you need to do is isolate this part. So in order to do that, I need to add 10 to both sides to get rid of this. So now I have the absolute value of 3x plus 9 equals 6. And we're just going to set up our two equations. Either 3x plus 9 equals 6, or 3x plus 9 equals the opposite of this, which is negative 6. And the first step in both of these is to get rid of this. So we're going to add 9 to both sides for both equations. On the left-hand side, this leaves me with 3x equals negative 3. Over here, the left-hand side leaves me with 3x. And then on the right-hand side, I have equals negative 15. So now I'm just going to solve both of those like I normally would. Both of them, I'm going to divide both sides by 3. When I do that, on the left, I have x is negative 1, and on the right, x is negative 5. And when we go back and plug both of those numbers in, they both work. So we write our answer as x equals negative 5 and negative 1. Well, what happens when you have absolute values on both sides? We're going to set it up the same way as we did before with our two equations. So on this one, I just rewrite everything without the absolute value signs. And then the other case, I'm going to rewrite this part, 4x minus 10 equals 2 times the opposite of all of this. So that means I have to multiply everything in there by negative 1. All right? Let's look at the left side first. So that would leave me with 4x minus 10, and then when I distribute this 2, I get 6x plus 2. Decide which side you want your variables on. This time I'm going to put them on the right, so I want this over there. I'm going to subtract 4x from both sides. Leaves me with negative 10 equals 2x plus 2. I want the 2 over on the other side so that this term is by itself. So I subtract 2 from both sides, which gives me negative 12 equals 2x. Divide both of those by 2, and you get x equals negative 6. All right, let's look at this part over here on the right-hand side. So when I do all this, I get 4x minus 10 equals 2 times negative 3x minus 1. Remember, I'm taking the opposite of all of this. And the opposite of all of that is negative 3x minus 1. Distribute the 2. That gives me negative 6 minus 2. I want the variables on the left-hand side this time. Again, remember, I always like to keep my variables positive. It doesn't matter if you did it on the right, you'd still get the right answer as long as you did everything correctly. 4x plus 6x is 10x. This is 0. It's what I wanted it to be. And now I have to get rid of this, so I'd add 10 to both sides. Leaves me with 10x equals negative 8. Divide by 10. My answer is negative 8/10. And you could write that as a decimal if you want to. Alright, next page. So you're going to come across word problems where you have to write an absolute value problem or equation to solve it. So let's look at this example that I've written down. In a cheerleading competition, the minimum length of a routine is 4 minutes and the maximum length of a routine is 5. Write an absolute value equation that represents the min and max lengths of a cheerleading routine. Alright, so we know what the minimum and maximum values are. And if you picture those on a number line, here's the minimum, here's the maximum. You want to find the midpoint, the exact middle between those, and the exact middle is 4.5. And then you want to find the distance that's between the halfway point and the endpoints. And because this is the halfway point, obviously these distances are going to be the same. And the distance from this to the midpoints is 1/2. Alright, so this is how you set up your equation, your absolute value equation. maybe I should have, let's see. Let's look at the right side of this first. So you take x and subtract the halfway point, which is 4.5, and set it equal to the distance from the halfway point to the min or max, which is 0.5. And you're going to need this right here to complete number 3, on worksheet 1.4. And that's how you would solve that. I didn't solve it though, did I? Well, let's do that now. Okay, so I have the absolute value of x minus 4.5 equals 0.5. So my two equations would be x minus 4.5 equals 0.5, or x minus 4.5 equals the opposite of that, which is negative 0.5. Add 4.5 to both sides on both equations. This would be x equals 5, because 4.5 plus 5 is 5. And this one would be x equals 4, because 4.5 minus 0.5 is 4. So x equals 4 and 5. We already knew that though. But this is how you would set up the equation. Alright? Okay. Let's talk about extraneous solutions. You may have never heard this term before. An extraneous solution is one that must be rejected because it doesn't work with the original problem. What does that look like? Well, I will show you. Let's say we have this problem. The absolute value of 2x plus 12 equals 4x. So we're going to go ahead and set up our two equations. Either 2x plus 12 equals 4x, or 2x plus 12 equals the opposite of this, which is negative 4x. We're going to subtract 12 from both sides, which leaves me with 2x equals 4x minus 12. I want this over here, so let's subtract 4x from both sides, which leaves me with negative 2x equals negative 12. And that gives me x equals 6. Alright? Let's see if we can see that better. Okay, so the second equation then, I'm going to put I want my x's over on the right, so I'm going to subtract 2x from both sides. On the right hand side, that leaves me with negative 6x. And on the left hand side, all I have is 12, so I'm going to divide both sides by negative 6 to get x by itself. So x is negative 2. So now we're going to test both of these answers from the original problem. Okay, so first we're going to see if 6 works. 2 times 6 is 12. 12 plus 12 is 24. 4 times 6 is 24. The absolute value of 24 equals 24. So 6 works. That checks out. Let's try x equals negative 2 in our original problem. Okay, so 2 times negative 2 plus 12, the absolute value, equals 4 times negative 2. So this over here gives me a negative answer, right? 4 times negative 2 is negative 8. Nothing in here. Well, let's just do it. Negative 4 plus 12 is 8. The absolute value of 8 is never going to be negative. So this answer, 8 does not equal negative 8, so this answer doesn't work. That means that x equals 2 is extraneous. It works mathematically, but it doesn't work when we plug it back into the original equation. And that is it for 1.4.